All right. Today we are talking about derivatives involved with tables of data, and not just derivatives, but just starting our introduction into tables of data. I think that you will see from here on out every single test, including the AP exam, will always have a question involving a table of data. Okay, so this is something we're definitely going to have to really get used to being comfortable with, understanding what the meaning is, how to work with them, how to answer questions about them. So getting into that world. A couple things that we want to make sure we do is read the directions, which is, I know that sounds funny, but it's not something I would have always done at a level lower than calculus. And sometimes there's some important information for us up there, a lot of things that are going to mean stuff to us, like the labels for our variable and our function. The fact that they tell us that this is a differentiable function is going to come back into play here in a couple questions. Things like that, and what interval we're looking at, all of those things. Some of the questions do not require much work. For example, the first one, use the data in the table to find W of 8. Okay, well, can't I just look at that table and say what W of 8 is? No work to be done on that. That's just reading the table. 8 stands for our number of hours. We're plugging it into W. I don't know what W is, but I can get the information from my table. W of 8 is 221. More importantly is the label. 221, yes.
It asked you a value that wasn't on there. What would you run linear regression or something?
No, they won't ask you a value that's not on there. We're going to see some where they ask us to like approximate like a derivative of one that's not on there and how we can do an approximation for it, but we won't actually be able to come up with a function for these. Or be asked to, maybe that's what I should, we won't be asked to come up with a function for these, like using a regression or anything. Nope, so yeah, good question. No, we won't have to come up with a regression and a value that's not on there. So, but involved with this, we will always be asked about the labels on them, okay? So 221, what's our label for that? Gallons, okay? It does have a second question to it. It says, explain the meaning of your answer. Okay, so what does it mean, 221 gallons? Well, go back to the x value, the t value that we plugged into this function. 8 represented what? Hours, right? It's 8 hours. And then we kind of go back up to the situation. It says the amount of water in the tank is modeled where t is measured in hours. So after 8 hours, there are 221 gallons in the tank. That would be explaining the meaning of my answer in a sentence. Okay. Any questions on that? Okay, so then this is another example of something that happens in calculus all the time, is that they just take for granted we remember all that math that we have been taught over the last forever, 17 years. And so a symbol like this, we haven't talked about this year, but we've been introduced to that before this class. What is W raised to the negative 1? When we're in function notation. Inverse. It's the inverse of our function. And if you remember the inverse of our function, the inverse is plugging in the y value, getting an x. Inverse is flip-flop your x's and y's. So now we're saying, okay, well, the inverse of W at 257, that's where we actually scan through our second column there. So at 257, that would have been 12. And again, labeling and explaining the meaning of our answer. So our label for that 12 from our T column, that would be in hours, right? So 12 hours. And again, explaining the meaning of our answer. When there are 257 gallons of water in our tank, 12 hours would have passed. Okay. Any questions? And I know I didn't write that out on the board there, but understanding how to write out a sentence to explain the meaning of our answer, labeling, reading the so far. Okay. So again, sticking with that table this whole time, our next question is this. Use the data in the table to approximate, and then this is where we have to be careful because this looks similar to last question, but it's W prime, which we now know means our derivative, right? And this is where we got to also kind of remember what that's related to, W prime of 15. And we are finding an approximation for that. And so let's talk about how we can find an approximation for the derivative at 15. Well, the derivative at 15 would be the slope of the tangent line. Yes, with me on that? Okay, so if this is my function, and let's say 15 is right here, we want the slope of the tangent line, but I don't have 15 in my table, do I? And so we'll use another thing we learned about that was related to the slope of the tangent line, and that was, what if I went on either side of it and looked at the secant line? Okay, secant line being our average rate of change between those points. And what we want to do is strategically pick our points so that it would sandwich 15. Okay, so if I look up at my table, if I want an approximation for the derivative for the slope of the tangent line at 15, I'm going to go on either side of 15 and find the slope of that secant line, or use my average rate of change. Well, 15 would fall right between 12 and 16 in my table, right? So that's the two values I would use, these two right here, in my average rate of change formula, or the slope of my secant line formula. One of the things we have to always do is show our setup, show the computation. That will always be a point, always, okay? Whether you do that in function notation or with the numbers, that's not as big of a deal. I'll show the function notation and the numbers. So we would do W of 16 minus W of 12 over 16 minus 12. That would be my setup. And from here you can jump to your answer, or you can show a line of work and then go to your answer. My line of work would be actually evaluating W of 16 and W of 12, evaluating by reading my table, right? W of 16 being 294, W of 12 being 257. 16 minus 12 would be 4. And then going to my answer. Does my answer need to be in a fraction or a decimal? Doesn't matter. As long as they are equivalent forms, as long as I round correctly, which this one we wouldn't really have to round much because it's less than 3 decimals. But let's see, 294 minus 257. And I can just leave it as 37 over 4 as well, okay? And then always, always, always putting a label on that. And remember, just use the labels from the fraction. Our function, W16, W12, function is labeled in gallons per or over, and then our plain T values are labeled in hours. So this would be gallons per hour. Okay. 37 over 4 would be whatever the number that simplifies down to per hour. It would be that rate. 37 gallons per 4 hours, or whatever that is as a decimal. So 37 over 4. Where's my calculator? So 9.25 gallons per 1 hour. Yeah. But yeah, we just label it as gallons per hour. Okay. Any questions on that? All right. Oops. Okay. And then they again kind of prompt us on this one, but it says use the data in the table to find the average rate of change, and then they give us an interval to use. Over the time period from 4 is less than or equal to t is less than or equal to 20 hours. Show the computation that leads to your answer. It's that same formula we just used. Remember, there's our formula. The interval they give us comes from this, 4 to 20. And so 20 would be B, 4 would be A. I go grab those values from my table above. W of 20 minus W of 4 over 20 minus 4. Same process, different prompting, right? Okay. And again, it wouldn't really matter if I use the first or the second way to set up to show my computations. I would probably use the first. But always showing my setup. 143 over 16. Now, if you were to go to the decimal on that, it would need to be rounded correctly. And remember to round correctly in calculus, that is 3 decimal places. So 8.938 if I rounded to 3 decimal places. And that is again in our gallons per hour. Any questions on our average rate of change? Okay, last one. For 0 is less than t is less than 24. Must there be a time t when the tank contains 265 gallons of water? And the biggest part on this one is the justify your answer. The yes or no would be at most 1 out of 3 points on this. Okay, so the justify your answer is what I want you to focus on as you are jotting down notes for yourself. So part of this is going back to what I highlighted at the beginning. This is a differentiable function, right, as identified for us in the directions. That's going to come into play as we answer this part in our justification. So is it ever going to contain 265 gallons? As you look at where it starts and where it ends, it starts down at 150. We see it goes up, 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 and ends up at 357. At some point, would it have had to have been 265? Yes. Now, we know that kind of logically thinking, but another part of it is the fact that it is differentiable. If you remember, we talked about that differentiability implies continuity, right? Because we were told it's differentiable, we also know I can trace this whole thing from 150 up to 357 without picking up my pencil, which means it has to. It's continuous. So part of it is that I can guarantee that it is continuous by the fact they told me it was differentiable. Then we learned this little theorem. Remember which theorem I'm talking about that guarantees a value exists? Yeah, IVT, intermediate value theorem. So how do I then put this into a correct justification? I will highlight for you. First things first is you are going to identify the fact that you know this is a continuous function. So W of t is continuous. We are going to find, since they asked us about a specific value, and we know it's up there, we're going to find values on either side of it where it's going to cross over. Now, the ones you pick specifically don't really matter, but we want to pick one lower and one higher than 265. I would probably pick the ones on either side of it, which actually would be the two we had used earlier, 12 and 16. I would just highlight for that for my justification. And also, W of 12 equals 257. And W of 16 equals 294. Okay, and again, I picked those two strategically because they're on either side of 265. You can pick any values on either side of 265. Okay, so this combination right here is what I need to say. And so a little math symbol here, therefore, there exists some C or T, the intermediate value theorem uses C, so I'm going to say C, on the interval from 0 to 24, such that W of C equals 265, and this is also the key. And I know this by the intermediate value theorem. Okay, so where are the key points on this one? That I cite the fact that I'm using the intermediate value theorem, that I point out the fact or I confirm that it is a continuous function, and that I show that values exist on either side of whatever value we're trying to guarantee exists. Okay, those are your key highlights when using our intermediate value theorem in a situation such as this. Any questions for me on that? Okay. Last couple of questions, we are going to turn to our calculator. Sometimes you'll say, okay, well, this is a model that actually would work for that function that you're seeing for the data in that table. And it says a model for the amount of water in the tank is given by this. A of t equals, and then that's the entire big ugly function for that. And it says A of t is measuring gallons, t is measuring hours. Find a prime of 15. Remember, prime means find the derivative. Okay, well, we have a function on our calculator that we learned that will do that for us, right? So we are going to go find the derivative of that function at 15. That is your Math 8 option. Some calculator notes that I've been noticing that people tend to make mistakes on this. When it says a negative, you have to use your negative key. Negatives and subtractions are not interchangeable in those situations. So make sure you use your negative key on that. So let's all try this on our calculator. Go to Math 8. Make sure you remember how to correctly type this into your individual calculators because it's a little bit different per operating system, right? And I'm pretty sure I remember that the answer was 9. So if you are not getting 9 at the end of that, let me know or have your table partners check over what you typed in. Let's all make sure we can get, somebody confirm that when you get there. Pretty sure it's 9. That whole thing, it starts at the 1 over 225. So that is all part of your function as we are typing this in. Okay, so a little get to know our calculator moment. Make sure we all get 9. Somebody confirm they got 9. Yes, okay. Make sure I was remembering that correctly. And if you don't know how to type that into your numerical derivative, this would be a good time to ask. Negative. And if you've checked over, guys, it can be little things as we go. Let me kind of check your calculator. A lot of times I can spot what got typed in incorrectly. If you're done with that, will you go type that function into y1? Use x as your variable. You got to put in a negative instead of a subtraction.
Oh, okay.
And that I didn't look at the rest of it, but that should fix it. Go type that into y1. I'm going to show you a little calculator trick here. Do you have the rest of it? Oh, that's not what I wanted. All right, you got that typed into your y1. We're going to look at the last question together. So we did the derivative at 15. We used it, let our calculator do the numerical derivative for us. Done. Okay. The last question is this. Use the model given here, so the equation given here, to find the average rate of change, fancy word for slope, right? Average rate of change over the time period 4 to 20. So we are doing A of 20 minus A of 4 over 20 minus 4, right? Average rate of change. Now, your calculators, you have several ways you could evaluate this. One of it is you could just type in this big, ugly function twice, one of it typing in a 20 and one of it typing in a 4. But I want to show you some other options that you may or may not be aware of on your calculator. So I had you type this into Y1 for this reason. If I quit out of this menu, I can evaluate my function using my YVARs menu, and it will plug in any number to the function typed into my Y equals. So if you go to this right here where it says vars, and arrow over to where it says YVARs, under function, you can go pick any of those that you have something typed into. We have it typed into Y1. And if I want to evaluate that function at a particular number, I want to, in this problem, evaluate it at Y equals, or at 20, right? I want to plug 20 into that function. I can put a parentheses after it and tell it to evaluate that at 20. Okay? So we could just do that and get the function evaluated at 20, or I can just type that whole thing in, either just the top or the entire fraction. You could do that entire fraction if you wanted to. Go grab your YVARs. And I want to evaluate it the first time at 20. And then I want to evaluate it at 4. So go grab that again. Evaluate it this time at 4. And we can put 20 minus 4 or 16 down in the bottom. And we've now typed in that entire average rate of change formula into our fraction at one time and just hit enter. Now, we can leave our answer like that. We can go to a decimal. Again, equivalent forms, it makes no difference. So I can go to math 2 if you prefer it in the decimal format. 8.996 would be our answer. And always labeling our answer here, we are talking again still in gallons per hour. So little shortcuts to kind of speed up your process on your calculator. Any questions for me? All right. Your assignment tonight is the derivatives with data worksheet. There is no room to work on here. So you guys are going to want to have your own piece of paper.